Good day to you. So today we're going to talk about Pascal Triangle and Binomial Theorem, or actually mostly Binomial Theorem that actually gets help from Pascal Triangle because they are related to each other. All right, a binomial theorem, or the idea of binomial theorem, is basically a form of expansion of this x plus y power. So in whichever form of this power is x plus y to the n, how we expand that, and I have written here a different progression of expansion of this binomial, and then we're going to look at some patterns. Okay, so I went through the first four exponents, or power of four, and expanded what I see what will happen. So x plus y to the power of 0, that's 1, because anything to the power of 0 is 1. And then, of course, x plus y to 1 is equal to x to the 1 and plus y to the 1. All right, and then x plus y squared, that's binomial squared, and that is basically you expand it, you get x squared plus 2xy plus y squared, and so forth and so on. Now, you may not know how to expand x plus y to the power of 4, but if you actually do the long-handed form of expansion, you're going to get this. All right. Now, what I have done, I have color-coded the coefficients and the exponents. Okay, that's what I have done, including the 1. Now, this one should be green. I need you to pay attention to these color-coded values. Coefficients are blue and the exponents are green. And notice that there are connected to the original exponent of the binomials that I've written. Okay, and then we're going to talk about how we can get these coefficients. But I need you to see the pattern is such a cool thing. And that's where the Pascal triangle comes in. Okay, so in order for us to see where we get the 2, this 1 plus 1 on top, these two together, that will get you 2. And then 1 and 2, that will get you 3. So as 1 and 2 gets you 3 as well. Now, notice that in every case, you start and end with 1 for coefficient. Now, 1 in here, 1 in there. Doesn't matter what exponent you have, 3 or 4 or 7 or 10 or 200, doesn't matter. You start with 1, you end with 1. The next thing that I need you to notice is the highest degree of any of the terms in that expansion is always the original exponent or power. So this is 2, none of these. So this is exponent of 2 here, that's exponent of 2. The degree of this term right here is also 2. 1 plus 1 is 2. So none of them will be bigger than that. So here is another, let's put 1 in here, 1 in there. So again, 2 plus 1 is 3, 2 plus 1 is 3, and that's what that is. 4, you get 3 and 1, 2 and 2, 1 and 3. They're never bigger than 4. Okay, and those are the exponents. And the other thing I need you to notice is that first term starts at the highest exponent that you have, right? So x in here, x cubed, is right here. And then there is no value for y, but there is. And I'm going to write one of them. So I'm just going to go to the x squared, actually, right here, x plus y squared, so that you can see it. X squared, y to the 0. Well, that is equal to x squared. Well, that's why we have only x squared here, because the y0 is 1, we don't put it in there. All right, so the degree, the exponent of y is 0, the exponent of x is 2, which is the maximum that you start up with. And then you go ahead and you see the pattern that x decreases, the exponent of x decreases, the exponent of y increases. So y becomes, from 0 becomes 1, next one is 2, and x decreases, goes 1, and then 0. And this is true for every single expansion. All right, so that's the exponent piece. The next piece is the coefficient. The coefficients are following the Pascal triangle. So remember, it starts with 1, end with 1, and in between, you're adding the top 2. Look at 1 and 2, 1 and 2, and here 1 and 3 is 4, 3 and 3 is 6. And then, of course, it lands with 1 in each case. All right, and we can go ahead and make a general statement with x plus y to the n. Turns out that all of these leading coefficients are actually a form of combination. You start with the highest value of n, you say n chooses 0, and this 0 comes for the power of y, which is 0. Okay, so n choose 0, and then you start with x to the n, y to the 0, plus, and then this is the coefficient, and that's the term. And then as you go ahead, you add 1. Remember, y exponent increases and x exponent decreases. So n to the n choose 1, x to the n minus 1, y to the 1. And notice that when you add n minus 1 and 1, that gets you n. Never ever exceeds the exponent the power of the binomial expansion. And you just continue this. So this next one would be n, choose 2, x to the n minus 2, y squared, and then plus the last piece will end up being the n, x to the n minus n, y to the n. I want to walk you through the Pascal triangle as I am rewriting it. Okay, we start with 1 on top, then 1, 1, then 1, 2, 1. Remember, we are adding the 2. That's what you're doing. The next one will be 1, 3, 3, 1. Next one will be 1, 4, 6, 4, 1. Always just starts and ends with 1. 1, 5, 10, 10, 5, 1. And you notice that this is your exponent 0, which is right here. This is your exponent 1. This is exponent 2. These are n values, okay? The n values for the exponents, that's what they are. So that's what we're using right here. This is n right there, all right? And as you go through this, you notice that the expansion is very straightforward. It's just a Pascal triangle as you adding the top 2 and then getting the next successive term for the expansion. All right, so that is the Pascal triangle, and basically the leading coefficients or the coefficients of the expanded form of the binomial expansion. And this is basically a binomial theorem. That's what it is. Now, to put them all together, this is using the combinatorics that comes up with these values for Pascal triangle. And by the way, the whole concept here credited to Isaac Newton, but it goes back. It goes back about 400 or 500 BC. It starts with Euler, and then you have Al-Khwarizmi, and then some Chinese mathematician Jian, as well as you have later on Pascal. And so basically it's a combination of work of many. So this is the expanded form of a binomial theorem. And all of these combinatorics or combination values, the coefficients for each of these terms are based on the combination that we talked about. And I will put a link in the description below for all the previous lesson that leads to this so that you go ahead and review that as well. But that's what you would do. Okay, let's go through a couple of examples of how this is going to come up useful. All right. So let's expand x plus y to the power of 5, okay? And we're going to go through and then use this expansion form, and very simple, all right? So we start with 5, choose 0, x to the 5, y to the 0, plus, and then you just go through 5, choose 1, x to the 4, y to the 1, plus dot, dot, dot. And at the very end, you get 5, choose 5, this plus there, x to the 0, y to the 5, okay? When you expand all of this, what you will end up getting, you will get this expanded form. And notice x to the 5, and you get 5x to the 4, y. Remember, 1 is right here, that's y to the 1, and that's why it's never exceeds the exponent of 5. And then you go down and then you look at each one of these, and then you just expand it based on this form. And or you can double check with the Pascal triangle. And look, we have 1, 5, 10, 10, 5, 1. Look at this one, 1, 5, 10, 10, 5, 1. And notice that this is the top one. This was the exponent 4, x plus y to the 4, which gave you this one, 14641 with 14641. But the next one, if I rewrite that one as x plus y to the 5, you will end up getting all the coefficients that are related to this. all right, that's exactly what we got. All right, excellent. Okay, one more thing that I need to share and make sure that you know, every time that you look at the expanded form of a binomial to the exponent of n, notice that the exponent is 1 and the number of terms is always 2 or 1 plus that n. So if you have x plus y squared, which is n, you have 3 expanded terms. If this is exponent 3, x plus y to the 3, you get 4 terms. X plus y to the 4, you get 5 terms, and so forth and so on, okay? That's why x plus y to the 5th, you got 6 terms, and so forth. So those are patterns that you need to pay attention to. But that's basically it. And then let's look at the put them all together. Remember that there are three things that you should remember. Pascal and a binomial expanded power of n for the Pascal triangle is always starts and ends with 1. Sum of the coefficient is 2 to the n. This should say 2 to the n. All right, and it is true, always is 2 to the n, the sum of the coefficients. So look at that one. 1 plus 1 is 2. 2 to the 1 is 2. Here, n is 2, so 1 plus 2 plus 1, that's 4. So that's 2 to the n, that's 2 to this 2 to the 2, which is 4. So that's 4. And this should say 8, which is it is, because 2 to the 3 is 8, 2 to the 4 is 16. When you add all these coefficients, you're going to get 16. Now, of course, the last one, the number of terms, is n plus 1 always. Now, one last thing, and putting them all together, if you have x plus y to the n for any specific term, this is the formula that you can use, and basically a shortcut. K is the term you're looking for. And I'm going to give you an example. The fourth term is right here. I put an example down here for you. And then n choose k, x to the n minus k times y to the k. There's another version of the same formula. There is based on only k, but then you have to change the top. This minus k becomes minus k minus 1 in bracket, and so as this one will be k minus 1, that could become a little more uglier. So I rather you use this one. My students found this much easier to deal with. So let's look at an example. Find the fourth term of the a minus 2b to the 10. Two ways you can do this. You can expand it right from the beginning and they get the fourth term, or you can just use this form or this shortcut to plug it in, and then they get the exact fourth term without expansion, without full expansion of the binomial. Let's start with 10, choose 3. A to the 10 minus 3 times negative 2b to the 3, and that is your fourth term. When you do the math, you get 10 factorial over 3 factorial times 7 factorial. That's your 10, choose 3. A to the 7 times negative 8 b to the 3. And the final answer in here will be negative 960 a to the 7 b to the 3. That's negative. That's the fourth term of this binomial expansion, a minus 2b to the 10. Okay, all right, that's it for today. Make sure you check out the next video in the series, and take care.